All right, so ladies and gentlemen, I want to say a big welcome to all of you to the Valley of the Shadows of Management Science. We have looked at probability. And if you guys can remember, we have looked at binomial distribution. Exam is coming. We have looked at Poisson distribution. Do you remember the two main differences between the binomial and the Poisson? Do you remember? Do you remember? There are two main differences between the binomial and the Poisson. Okay. The binomial looks at exact probability. The Poisson looks at the mean probability. Poisson has an interval. So it talks about something happening within a period of space or time or a certain length. Binomial has no interval. Okay. And when you are doing binomial, you need 4 elements. The P, the 1 minus the P, the X, and the N. But when you are doing the Poisson, you need 2 elements. The X and the mean. The X and the mean. So take note of this. Okay? So these are the main key. Now, the last distribution we want to look at is the popular. And that is the normal distribution. But before we do that, let me just remind you of some few things. There's a difference between the word parameter and a statistic. Parameter is a number that describes data from a population. So when I pick the mean from the population, that mean becomes population parameter. But when I pick it from a sample, it becomes a statistic, mean statistic. Okay. So just know that a sample is a portion of the population. Therefore, a statistic is something that describes a portion of the sample, or that describes the sample as characteristics of the sample. And that is a statistic. Now, with this in mind, you should know that the mean of a sample is given as X bar. That's the mean. The mean of the population is given as mu, mu for mu. The standard deviation for the population is given as sigma, sigma. And then the standard deviation for the sample is given as S. Everything about a population is a parameter. Everything about a sample is a statistic. These are basic, undergraduate. So with this in mind, let's look at a continuous probability distribution, because we have looked at discrete probability distribution. Those are the ones we looked at. A continuous random variable is not the same as a discrete random variable. By the way, what is a random variable? Look at the word random. It happens, by that. But this one is continuous. In short, it is not, it's a decimal, just to give you an idea. It's a decimal. So the moment you start thinking about things that are continuous random variables, they are decimals. Things that are discrete random variables are not decimal, like gender. But when you think about things like age, age can be a decimal. She can be 2.5 years, 2.4 years. You can do a lot of conversion. What else can be decimals? Think about that. They are all continuous random variable. They assume any value in an interval on a real line or in a collection of intervals. And the key thing is that it's not possible actually to talk about the probability of a continuous random variable, assuming a particular value. No, you can't. So the probability of a continuous random variable is always supposed to be equal to 0. you know, that is for the continuous random variable. But if there are several of that, we are not talking about the continuous distribution function or the cumulative distribution function. The cumulative distributive function of a continuous random variable is this. Don't worry, all of these things, I'm just worrying your head small. I just want you to know that you are a master's graduate, a master's student. All of this, you don't really need to fully understand it yet. It's just for you to know that you are masters, you see, just to distinguish yourself from what you did in the good old days of undergrad. Now let's get into the real way. What is a normal distribution? First of all, what is a distribution? The last time we looked at a distribution, what is a distribution? The way certain numbers are looking like, the way they are looking, the way they look is a distribution. Now, if the distribution is normal, it means that we have a probability model and it is showing an observed behavior of a data sample that is copyable in real life. This distribution is observable in real life. And there are so many things in life that are exhibiting normal distribution. Psychological, educational variables, monetary variables, all of them are approximately normally distributed. They are not Poisson distributed. They are not binomially distributed. The normal distribution was introduced by a German mathematician known as Carl Friedrich Gauss. So sometimes it's called a Gaussian distribution, the bell-shaped curve, the bell-shaped curve. One day, if I introduce another distribution, you may get Asari's distribution. Or when you do it, that is if you would do it. Okay, you can have yours. So let's look at certain things that are normally distributed. Your height is normally distributed. Why? Because basically it can include decimals. You can have 5.5 feet, 5'7" inches, 5'84" inches, and all of that. Your weight is normally distributed. You can have $3,144. So incomes are normally distributed. Ages, I've already said, are normally. Your test scores, some of you will get 55.5, 58.9. Okay, your test scores are normally distributed. The size of your shoe, okay, somewhere, 7.4, 7.5, 11.2, and all of that, they are all normally distributed. The blood pressure can be 68, can be 72, can be 84. These are all normally distributed, and so many things. Very, very common. So that is why I'm singling out normal distribution so perfectly here, because it's practical. Now, how does it look like? If you guys can remember anything that is binomially distributed, it looks like something like this. So if you have the distribution, the probability density function is here. And you have the distribution, binomially distributed, okay, you have 0, you have 1, you have something like this, you have something like this, you have something like this, you have something like that, you have something like this, you have something. So if I were to throw a line to them, the line goes up to the hit, come down, up to the hit, come down. It goes the same level, okay, the same level, okay? The top and down, that is binomial. Now, when it is rather Poisson distributed, you remember how we indicated Poisson distribution. Okay. Depending on how it looks like, okay, exponential distribution is this, and then you have the Poisson that way. Now, if it is normal distribution, what we are saying is that it is illustrated by the bell-shaped curve. What you have to understand is that, of course, you all know the bell-shaped curve. The bell-shaped curve is like this. I will come back to it properly. That bell-shaped curve is a distribution of something. That something can be ages. So you can have ages here. Okay. And then you can have the probability of that ages here. And you can see that the ages are normally distributed. The peak is telling you where majority of the ages are located. And it is supposed to be the mean of the distribution. Because I use the word where majority of the ages of the people are. Now, sometimes some of the people are, majority of them are in a certain place like this. Okay. So you may have a group of them, let's say you have 100 people, and you may have 40 of them are in the age of 20. Just suppose this is 20, and then this is 50, and majority of them are in 20, and then majority of them are also in 50. So in this case, you wouldn't have something that is normally distributed. The distribution becomes bimodal because it has two modes, two ages that are dominating. But when majority of people are located in one particular age bracket, that is what we are talking about here, normal distribution. The area, this is where you want to understand, the area under the normal curve is the most important thing. That area under the normal curve is what we call the probability. The entire probability is the whole space under the normal curve. I mean, just remember something like a box, okay? Or let's say a rectangle. A rectangle has got a length and breadth, or length and width. The whole area, if you want to find the area of this rectangle is the length times the breadth. That's the area. So that area is the space that is encircled. The space that have been encircled by the rectangle. Together, of course, with the line, the bordered line. The same thing when we talk about the area of the normal curve, the area of the normal distribution is this whole space covering that normal distribution, covering the bell-shaped curve. And what is interesting, guys, is that this area is always 100%. It's not like a rectangle or a triangle. A triangle is half base times height, you remember? Okay. That is a triangle. Okay. So when we look at a triangle, the area is half BH. And it changes, isn't it? The base can be different, the height can be different. So at each time you can have different. The same thing with a square. The same thing with a rectangle. The same thing with any quadrilateral or a polygon. They change. But then the area under the normal curve doesn't change. The total area under the normal curve is 100%. It's always 100%. And what you want to do is, and we say is 1 is 100%. And what is interesting is that because the left portion of the area equals the right portion of the area, it means that each one would be 0.5, 0.5 if the whole thing is 100%. But what we are going to do here is that I know the half is 50%, the other half is 50%. But what if I want just this portion here? Okay? Just this very portion I've just shaded right now. What is that area? Aha! That one, you know that that is part of the 50%. And that's the essence of what we are going to do. But what will even make somebody want to ask you a portion of that area? Well, life is not a straight line. Life will ask you. Sometimes you don't want, no, sometimes you are dashing somebody money. So I don't want everything. I want to just see, oh, then that is too much now. And that means he wants a portion of the area. And that is why life will make you want to discuss a portion of the area. You know, sometimes when you're talking about a person's age, you say that you remember the time when you were between 2 years and 7 years. Do you remember that time that your child was like, Mommy, I don't remember that. Oh, okay. What about when you were 10 years? The time you were 10 years up to the time you were 17 years. We lived not in Accra. We were in London. So say, I kind of remember that. You see, you are using a portion of the age to speak. And you can use a portion of anything. Now, the mean of the normal distribution is the center. So the center here is the mean. And anything away from the mean to the right or to the left, anything away from the mean is the deviation from the mean. The deviation is also called the skewness. If everything is located perfectly in the mean, then the skewness is 0. Okay. And when is the skewness 0? The skewness is 0 when everybody has the same value. So let's say they are talking about 20 children and all of them are aged 8 years old. So it means that the deviation from them is going to be nothing, 0, 0, 0. That deviation becomes a skewness. Sometimes also called the standard deviation. That is how you document the skewness. It's sometimes called a spread. Okay? It tells you how flat or how wide the whole thing is. If you have a bigger value, a bigger skewness value, it means that you have more spread. It means it's flatter. The curve is normal, but it's flatter. So for example, you can have two normally distributed curves. They all have the same mean. They all have the same mean. You can have something like this. And then you can also have this one. They all will have the same mean. The center is the same. But then you can see that the spread might be different. And even the peakness is also different. Okay, so small standard deviation will lead to less spread. That means it's taller. So this one is taller, which means that the standard deviation is very small. Because the density of the curve, and the total area is 100%. So whatever you do, you change the weight, it's compensated by the height. For example, as you squeeze the thing, then the height will become taller. As you stretch the thing, open it, then the height will come down. That's how it's behaving. I wish I had a machine to show you. But hey, I know you get what I mean. You're the smartest people I've ever known. So let's look at the distribution. Now that because anytime you're talking about distribution of something, what do you use? You use the mean and the standard deviation. That's what we've been doing with the binomial. That's what we've been doing with the Poisson, the exponential, the truncated normal distribution, the Weibull distribution, log normal, log linear, everything, all of them. We use the mean standard deviation, the mean standard deviation, the mean standard deviation. That's what we use to describe a distribution. So we use the mean, we use the standard deviation, and then it can tell us whether the thing is symmetric, unimodal, or skewed, whatever skewness, whether it's left skewed, right skewed, or anything. The population that follows a normal distribution is written as what you see down here. So suppose we say that X, which is a random variable, which can be age, height, weight, salaries, okay, and that's X. We say that X is normally distributed. That word you see here, that symbol here is the tilde. It's called tilde sign. Know it now. Tilde. Okay. Big letter tilde. Depending on where you are born, you say tilde, tilde, tilde. Okay. But depending on where you were born the ghetto blaster. Miami area, I can say tilde. Now, this symbol means that it is the distribution, it's showing the distribution. The N here means that X is normally distributed. The mu is a mean, the sigma is a standard deviation. So anything you can tell the mean and then the standard deviation. And if you have the mean and the standard deviation, you will know the distribution. The area under the normal curve, we've already said that it's called a probability. But you see, that area under the normal curve is not easy to determine. It's not like a box. It's not like a square where you can use length times breadth. No. It's not like a triangle where you can use half base times height. No. Please look at the area. It's not a small boy area. It's a very, very complex sort of area here. Look at that. How do you find a portion? Of course, you know everything is 1. The area is 1. Half of it is 0.5. The other half is 0.5. But how do you find this section here? Just this section here. Okay, how do you find that? It's not easy. It's the area of the whole bell shape itself is shaped in a way that doesn't make what you normally know. Even though so many things in life are normally distributed. But many people don't know that this is how it looks like. So we can measure that probability of the area, okay, by determining the number of standard deviations any normal random variable is, determine the number of that standard deviation, how it is from the mean. If you look at how far you are from the mean, you can now use that idea. But please remember, you are still going to determine the area. And you know that it's going to be under 100% because the total area is 100%. But here's a clue. What Professor Gaussian did is that he created a table. Of course, others have extended it slightly. He created a table that can help you to standardize any normalized variable. So I'll give you an example. Let's say you take the ages of people. Some of them are 40 years. Some of them are 80 years. Some of them are 4 years. Then you take the height of people. Okay? You know the majority of people, they don't go beyond 9 meters. Even Goliath, the tallest, most feet, okay? Feet, not much. Ladies are usually 5 to 6. Few of them will go 7. Very few. Majority of ladies are 4 something, 5 something, and all of that. So you look at the ages. Ages are generally between 4 and 7 feet. Okay. Sorry, I mean what do you call it? Not ages, but the height. And then you have weight. Weight, a person can be weighing between 60 to 100. Depending on whether you're dealing with kilograms or what. So you can see that the unit of measurement are different. Now, if you want to talk about these things, they are all in different units of measurement. And so if you want to actually compare these things, you need to look at the unit of measurement. And you can't say that, oh, my height is better than your weight. No. You can't compare that. They are not normal. They are not standardized. What the normal distribution Gaussian did is to standardize with a new number so that they become comparable. They become comparable. And this has been properly known as the Z table. So we use a certain Z that will help you to convert any normal random variable to this Z value. It doesn't matter what a random variable is. It can be in dollars, it can be in kilograms, it can be in volumes, gallons, it can be in cubic meters, it can be in square meters, it can be in anything. You can still bring it into this standardized number. Is that not cool? Is that not cool? And so here's how it is done. To be able to do that, you need to have a formula, and this is a formula. So this formula called, and please write this formula. It's called a normal distribution formula. You use it a lot too. Next time I'll teach you research methods. You will use this one in principal component analysis. That's what you will use. You use this in principal component analysis. So be ready, man, be ready. This is a wonderful formula. The X here is the random variable, a particular aspect of the random variable. Remember, it is not capital X. Capital X is all of the individual random variables. So what I mean is that, suppose we are talking about ages, okay, and there are, a certain number of people. Okay, one of them is 25 years, one of them is 29, one of them is 20, one is 40, and the other is 50. These are six people, five people. Each of these numbers is represented by X. So this one is X1, this one is X2, this one is X3, this one is X4, and the last one is X5. And when you put all of them together, we have capital X. So the capital X is a random variable, okay, for all of them. But then the small x is one of them. So now we can convert each of the one of these random variables, into a z value, as long as we know the mean and the standard deviation, okay, of the entire distribution. If you know it, you're good to go. And we know it, because whatever question it is, you will get to know it. You can always find the mean and standard deviation of anything, as long as you have a series. So this is how if the mean changes, what happens to the density? So you can see that here, the mean is 100, the density is 10. But then here, the mean remains the same at 100, but you reduce the density from 10, the standard deviation from 10 to 5. And the moment the standard deviation comes down, the thing is like squeezing the thing. And so the height goes up. And then, if you maintain the standard deviation, you see it was 10 before. Okay? The mean is 100, but suppose you increase the mean, the thing shifts. It becomes becoming a sort of left tail situation. So because you can see that the tail here is very, very low. So these are some of the things that you can do with the mean and the standard deviation. Now, let's talk. Let's properly talk. Normal distribution, this is the same thing as the normal distribution, but is the what we call the function, okay? The function of the normal distribution. And this is a complex function. If you look at it, it's a whole function. And the details of the function are here. You just need to know that we have something called the normal probability distribution function. And this is how it is. Okay. Remember that x can be negative infinity to positive infinity. Don't worry about this formula. Sometimes it looks weird to people. But the key point of this function is that this is what this very distribution we have been drawing comes from. Now, my focus today is to tell you, or for you to tell me, or for you to learn by the end of this course, be able to tell a portion of the area, which we know is 100. Now look at the first one. We have two numbers. The numbers are A and B. A is on the left of the mean, B is on the right of the mean. If you look at the left part of the mean, it is already 50%, you know that. So to be able to find the shaded area, we need to know this distance. And please note something, write it down. If you write it down, you will understand what we're about to do. Anytime you want to measure an area, you start from the center and move to the right. Anytime you want to find an area, you start from the center and move to the left. So the movement is from the center, then you go right, or from the center, then you go left. Center, you go right, center, you go left. Keep that in mind. And so if I want to know this area, I already know that the left section here is 0.5. I just need to move right from the center here, find this one. And this finding will be direct finding because you are giving the answers from the center to where you are going. That is different from the second one here. The second one, I know this is 50%. I don't need this area. The area I'm looking for is a shaded area. So I'm looking for probability that X is less than A. That's what I'm looking for. Okay? I'm looking for the area below the A. And if you want to find the area below the A, guys, watch it. You cannot just get up and find the area. Remember, we start from the center and move to the left, and start from the center and move to the right. So if I move to the left, it means I'll rather find this white area first. That's what I'll find. That's what I will get. Then you subtract the answer from what? You can tell us. Once you find this white area, you subtract the answer from what? Let me see what people are typing. 0.5, exactly, Salam, Dinah, okay? You find that you have to subtract it from 0.5. That is when you will now know the area you are looking for. Now let's come to the red one, the last one here. If you want to find the shaded area, you start from the center, you read this, you find this area, straight away you get the answer. You read this one to find the area, straight away you get the answer. Then what do you do? What do you do? What do you do? One word. What do you do? You find the area. What do you do? One word. Add. That's it. You add them. And that will give you that. And you expect that when you add the two, the total should be less than 100%. So these are the ways we find some of these areas. The practical work will help you to understand this better. Let's take a quick one. A very quick, easy one. Suppose the income of Kaya you sell is normally distributed. You have been told that it has a mean of 100. It has a standard deviation of 50. Now you are being asked that suppose I close my eyes, I pick a Kaya yo at random. What is the probability that this Kaya yo will make an income of not the mean income, but rather make 200? Serious. All the time, the first thing you got to do is to draw it. How do you draw it? Do it like this. Draw your normal distribution this way. Okay. Indicate clearly a beautiful normal distribution. Always indicate the mean. Write that the mean is equal to what you were given. This was 100. And put the standard deviation you were given also below it. This was 50. Then indicate with a line what you are being asked. You are being asked to find the probability that Kaya your seller will earn 200. Ask yourself, 200, is it to the right of the mean or to the left of the mean? The 200. Is it to the right or to the left? Good. It's to the right. So 200 is to the right. So you indicate that 200 somewhere to the right here. Then you write that number 200. But you have to shade what you are looking for. And what are you looking for? You're not looking for above 200. You're looking for the area from the center to the 200. So you have to shade it. This shading is very important, and it's important also in an exam because it helps you to know what you are measuring. Now, how do you get the answer? The area. Remember, we know the area is 100%. Well, the first thing you got to do is to convert this 200 to the standard normal table. You see, ladies and gentlemen, this is X value, all this line. But we can convert it to Z value. In the world of Z, the center number is equivalent to 0. And everything to the right of the center is positive. Everything to the left of the center is negative. In the world of Z, not in the world of X. In the world of X, you can see that the center is 100. And to the right of the center is above 100. And to the left of the center is below 100. But in the world of Z, the center is 0. And whatever is on the right of the Z, the 0, is positive. And it's the same thing that is on the left. Because the center is a mirror image of each side. So you can convert this whole thing using the Z approximation formula. What is that? It is given by Z equals to X minus mu over the standard deviation. Okay, how do you find the Z value? Well, substitute the values. X was given as 200. So you write that. Mu was already given as 100. And then the standard deviation was given as 50. Whatever answer you get, you must always convert it to 2 decimal places. I'll tell you why very soon. So what did we answer? What will be your answer? You must always convert it to 2 decimal places. So what will be your answer? Let me see those of you who understand 2 decimal places. Those of you who have written your answers are wrong. What you have written is wrong. Exactly. So now you are writing the correct one. It's supposed to be 2.00. So your answer will be 2.00. That is 2 decimal places. That is the Z equivalent of the 200. So using this Z, you can now find the probability. Guys, watch the channel we have been using. We were just able to find, we were given X, all right? We have used the X and we have been able to get the Z. Now we are using the Z to get the P, which is a probability. That's what we're going to do. How do you get that? You have to go and read the Z table. So right now I'm going to go to the Z table and you are given that Z table, if you can remember. I'm going to the Z table here. I'll wipe off this so that you can see it well. But remember the Z is 2.00. So let's go to the Z table. This is the Z table. And this table, it has different things which are used for other things later. But the table you're looking for is the one on the right here. Okay? This table is the same table you use. You're looking for the Z value. Look on the table. The Z value, in fact, this might not be, so let me make it bigger. Okay. Good. So there's the table. It should look bigger now. Oh, no, this one is too big. This is okay. So this table, the Z is what you have on the far left here. That's the Z. So all the numbers you are seeing here are Z. You are looking for the number 2. So you have to come down slightly. And when you come down slightly, you are looking for 2.00. 2.00, you get the 2.0 here. So you are left with the next 0. The next 0 is this one, 0.00. That is how you find it. If you have 2.22, you have to read 2.2 rather here, down here. Remember, suppose you have 2.22. Then you don't have to read 2.0, you rather read 2.2, which is this one here. And then you look for under 2. Under 2 will be here. 2.2 under 2. This last number, we call it under, and it is looked for at the top. So 2.0 under 2, sorry, 2.00 is going to be one number. Who can tell us the answer? You match the top value and then the horizontal value and then the vertical number where they meet. What is the number? Look on the table and tell me. You are looking at 2.0 under 0. What number is that? Who are the smartest people here? Who are the smartest people? Very good. 0.9772. That's the number down here. Okay. So you have the number here, and this is your Z, the probability value. Now, if you look at the direction of the movement, we don't have to subtract this from anything. And we get 0.977. We got it. This particular table, okay, this very, very table it requires that you subtract it from 1. Because the table here are all the way up to 1. Okay, it's not like the other table that we used previously. So you can see that the last number here is 0.99998, which is approximately 1. So this, and then you're going to see why this is so very soon. Okay. But first, this is your answer, 0.9997. Now you come here. If I used to have another table, okay, let me see whether it is here. No, not this one. No, not this one. Okay. There's another table which is usually easy to use, but it doesn't matter whichever one it is once you understand the principle. But if you want that table too, I'll give it to you. Okay, let me just clear this, and then we can interpret that number. So when you do all of this, everything I've done here is shown here. Now, when you get that value, you have to subtract that value. In this case, you have to subtract it from 0.5. See, the value you had, let me go back here. The value you had was 0.997. You have to subtract 0.5 from this, which will give you that. Please, just a second, let me just give you the other table, which usually doesn't confuse you. We have this table, and you're looking for 2.0. So let's come to 2.0. Okay, so 2.0 Z is still here. You read 2.0 under 0. Okay, so you see 2.0 under 0, and you get what? You get 0.4772. That's easy peasy, and that is how you are able to read this thing. And that gives you this answer, which is 47.72%. So what this means is that the chances that if I pick a Kayayo seller from the market, the chances of that Kayayo earning 200 cedis is quite slim. Why? Because we were able to find out the mean salary was 100 cedis. So the chances of a Kayayo earning double of what the average is, there's some chance, but the chance is not 50%, it's 47%. So that's what this one means. And that is how we can get it. Very good. So now let's take a practical one that will look for several ways you can draw and several ways you can analyze this. You will get questions on this multiple times. So let's take a real life situation and see possible probabilities you can calculate. Bogas. They sell furniture, they sell carpet. Are they still there? Is Bogas still around?
Yes, sir.
They are not. Oh, they are gone, right?
They are around.
Oh, okay. They used to be very, very popular. These days, there are a lot of foreign competition there in the market. Well, from years of sales record, management have found out that the mean number of yards of a carpet demanded by a customer during a week, the mean is 4,200 yards of carpet. And there's a standard deviation of 1,400 yards. So the manager wants to know, 1, the probability that if I select a sales, okay, what is the probability that demand for carpet this coming week will exceed? The word exceed is very important. What is the probability that it will exceed 6,000? Remember, the average is 4,200. Okay. What is the probability that it will be more than that too? And it will even exceed 6,000, 10,000, 100,000, million, exceed. The first thing you want to do is to find the mean and the standard deviation, and they have been given. The second thing you got to do is to draw. Okay. When you draw, and you always get marks for drawing, okay, and you must master the drawing. So how do you draw? Okay. Normally, I would have gone around to check 5 people who have been able to draw well. Normally. So Harold, you can do that for me. Check those who are drawing very well for me.
Yes, sir.
Okay. That is those who are not copying. Now, draw for me. Draw for me and let me be sure that you are good. Have you got someone who has been able to draw? So your X will be on this axis here. You have to draw the normal distribution like this. Indicate the mean. In fact, let me come down here so that you see it clearly. And let me just do it like this. So this is a normal distribution. This is a mean. Just indicate that the mean. And then if you write the mean without indicating it, everything is wrong. You have to write the 4,200 to indicate that that's a mean. You have to write 1,004 to indicate that that's the other deviation. Now you have to also indicate the one in the question. The question says 6,000, so indicate 6,000 first. So right here and indicate that this X is 6,000. Then you shade the area in question. So if you look at the areas, we have area A here, area B here, area C here. Which one am I going to shade? Which one are we looking for? A, B, C. Which one? A, B, C. Which of the areas are we shading? Because of which word in the question? Because of which word are we shading which area? Okay, good. We are shading C because of the word exceed. So you now have to shade. So if I check your exam situation and I see that you have shaded this, then I know that you have done the correct thing. That's the first mark. That's a method. Now, so it means that we are looking for this area. Okay, good. How do you get the area? First, you need to know that this is X, so we need to convert it to Z. So you come here, write your Z formula. Z is always the X minus the mu. X is 6,000, so you write your 6,000 minus the mu. What is a mu? 4,200. You write the mu 4,200 divided by the standard deviation. So you write the standard deviation 1,400. What is your answer? Who has found it? Correct to 2 decimal place. Don't forget that. Always correct to 2 decimal place. Who has got that? One point. You see, some of you have gotten it wrong. Parents. This is where Abdul Rahman also got it wrong. Very important. The conversion. The conversion is very important. Okay. If you don't convert it well, okay. Terence, you are right now. Abdul Rahman, you are still wrong. Dinah, you are right. Victor is right. Harold is right. So you should get 1.29. 1.29. Now that you've gotten the value, you go to the Z and go and read that. So go to the Z table. This is a Z table. You're looking for 1.2 under 9. You're looking for 1.2 under 9. You're looking for 1.2 under 9. Guys, I'm leaving you to read it. Who has read it? And who can tell me the answer? 1.2 under 9. This time you know how to read. 1.2 under 9. What is it? Let me see whether I've got some people cracking. 1.2 under 9. Salam, you got the right answer. Patrick, Redeemer, Dinah, you got the right answer. Okay. That is 8.4015. So this is 1.2. Okay, 1.2 is here. And the 9 is the last one. Okay. The last one, which is 0.4015. So that is the probability. But look, that is not the right answer for you. Why? Because look at the question. The question says you're looking for the area above, but this 0.4015 gives you the B area. Remember, we always read it by moving to the right. So what we've done is that we rather found the B area and not the area after B. So what do we do with this number? You subtract the number from 0.5. So this is how you're going to write your final answer. Okay. You're going to say that the probability that X is greater than 6,000. In fact, this is the same as the probability that Z is greater than 1.29. Don't forget. And this is equal to 0.5 subtracting 0.4015. So whatever you had, you have to subtract it from 0.5 to be able to get to the C area. Okay. So you have 0.5 minus 0.4015. That should give you, what did you get? 0.0985, I think. Okay, yeah, 0.0985. So that is your answer for the area. So now you have to speak about it in English. You have to talk in English, grammar. Okay. What was the question? Question says that, what is the probability that, so what this means is that the probability that demand for carpet will exceed 6,000 yards is very slim. The chances, the likelihood, the probability is very, very tiny. It is 9.85%. It's under 10%. So there's only 10%, there's less than even 10% chance that demand for capital will exceed 6,000. The chances are very slim. Okay? And that is what you have been able to calculate. So to expect that is quite an ambitious expectation. See, now you have a statistical knowledge and you can speak with authority. That good. Now, let's look at another situation. What is the probability that demand for carpet will be 5,000 yards or less? Harold, go around and let's see who will draw that. Okay. The probability that demand for carpet will be 5,000 yards or less. You see, that word 5,000 yards or less is an important word because the first thing you got to do is to draw it. So let's draw it. And again, you got to draw all of these and master the drawing. How do you do that? Let's draw 5,000 yards or less. Do that. So once again, you draw your normal distribution. Okay. My drawing is not looking good today. You draw a normal distribution like that. You show your center. Remember that you always have to write mu equals to 4,200. Standard deviation equals to 1,400. And we are looking at 5,000. Is it to the right of the mean or to the left? Obviously, 5,000 is to the right. So you indicate a number, a line here, and then indicate that that line is 5,000. Now, we are looking for 5,000 yards or less. So which area are we going to shade? A, B, C. Which area are we going to shade? 5,000 yards or less. Which area will you shade? Which area? Somebody says A, Del, A. If you shade A, that's wrong. Which area are we looking for? Esther says it's B. Esther, that's wrong. Dinah says it's A and B. That is correct. Victor says it's A and B. That's correct. Emmanuel says it's A and B. That's correct. You remember, it's 5,000 yards or less. So it's the whole of this area here. That's what you're going to shade. That's what we are looking for. Okay. Because it's 5,000 yards. Remember, below the 4,200, there is also 3,000 there, 4,000 there, 2,000, 1,000. So you're all less than 5,000. Okay. So now let's go to our Z. So you have to first convert the 5,000 to Z. And this is interesting because now what it means is that you have to find the area A. And we already know the area A to be 0.5. So we just need to find the area B and add it to A. And that's it. The Z is going to be 5,000 minus the mean, which is 4,200, divided by the standard deviation, which is 1,400. What value do you get? What value do you get? Okay. Remember, it is from Z, and you are going to what? You are looking for X, you are going to Z. Okay. Now, you have to round it. I think I've been talking a lot about rounding, and some of you are still not rounding. Round it, 0.57. That is a value you should get. Okay, you should get 0.57. Now, let's go to the table, because the next thing is to go and read the table once again. And some of them are tricky. It's not all, these ones are easy. Okay. You go to the table, what do you do 0.5 under 7? What value do you get? 0.5 under 7. What value do you get? 0.5 under 7. What do you get? 0.5 under 7. What do you get? 0.5 under 7. You should all be reading this. You know, somebody is sitting down here, and all that we are saying, the person is saying, where by force? Do some, say some, talk some, do, say some. Okay, that is how you grow. That is how you grow. Excellent. The day 0.2157. That is the answer. So 0.5 under 7 get to this junction here. That is your answer you're looking for. 0.2157. So now we can add that. Okay. So you see that the probability, this latter part of what I'm writing is very important. The probability that X is less than 5,000. This is the same as the probability that X is less than 0.5, sorry, Z. Z is less than 0.57, which is equal to 0.5 plus 0.2157, which will give you 0.7157. Keep this in mind. That is it. So the chances of you a carpet being demanded next week, okay, the probability of a carpet being 5,000 or less is quite high. The probability is high, 71% probability, because the mean we are told is 4,200. So if the chances of you getting less than 5,000, the chances are quite high. So that's how you work these things out. Now, the next thing is you can have a different way of addressing some of this question. The next one is, what is the probability that demand for carpet will be between 3,000 and 5,000? Between 3,000 and 5,000. Now remember, we have already found the 5,000. Okay. The 5,000, we had 0.2175, I think. So we already know that. What about 3,000? First of all, how do you draw it? Well, let's look at it. So this is how you do this drawing. First thing is that you draw your Z, as always. You draw your mean, as always. You showcase the mean, which is 4,200. Showcase your standard deviation. And you look for 3,000. Is it to the left or to the right of the mean? 3,000 is obviously to the left of the mean. So you indicate that here. So that is 3,000. And we also told 5,000. We already know that 5,000 is to the right. So you shade that one too. And we are told that this one is between the two of them. So you are shade. Okay, let me see. Which one are you going to shade? Is it A, B, C, or D? Did it?
Hello, sir. Sir, please, I'll type.
All right, okay. So it's going to be B and C, B and C. Most of you are saying B and C. That's good. Excellent. So it's going to be B and C. So that's why you shade. You shade B and C. Okay. We already know the value for C. If you can remember, it was 0.2175, I think. So you put that C down. Now you're able to find for 3,000. And how do you do that? Go to the Z and then do 3,000 and you're going to get a minus. And whenever you get a minus, don't worry, it's the same thing because this is a mirror image. So it is 3,000 minus the 4,200 divided by the 1,400. What Z value do you get? And by the way, I'm also going to show you how to write this one. What Z value did you get? You should get, let me see, 3 minus this one gets divided by that. 3,000, the mean is 4,200. The mean is 4,200. So obviously, this is because it is on the left of the mean. 3,000 is on the left of 4,200. That's why. So when you calculate this, you are going to get negative 0.8. Yeah, negative 0.86. So you get negative 0.86. Remember that when you are reading this, from the table, the negativity doesn't matter. Okay, as for this, when you are reading it on the table, it doesn't matter. So we get this value. So let's go to the table and go and read 0.86. So that means you're going to read 0.8 under 6. Okay. Who can tell me when you read 0.8 under 6? Don't say that my drawing has blocked your view. 0.8 under 6, what do you get? Some of you have never answered, either typing the answer or raising your hand to answer. Okay. Either way, you haven't. Remember to partake in your own rescue. So when you do that, you're going to get 0.3051. Excellent. So this is how you write it. The probability that I'm going to show you how you normally write it. Because how you write it is also very important. So you're going to say that probability that 3,000, and it is inclusive, is less than or equal to X. It's less than or equal to 5,000. That's the meaning of the between. This is the same as a probability that negative 0.86 is less than or equal to Z, is less than or equal to the 5,000. What was it? Was it 1.29? Man, I've forgotten that number. Or 0.57. Which one? Yeah, I think it was 0.57. Oh, let me see. The 5,000. No, not the probability. Not the probability. I'm talking about the Z value. Because how you write it is very important. The Z value for the 5,000, was it point? Yeah, 0.57. Good. So it's 0.57. So now, to get the answer, you're just going to take the answer you had for the first one, the 3,000. So this probability is going to be equal to 3,001. And the 3,000.86, when you read that 0.86, you got 0.3051. You add that to the what's that? 0.2 something 57. That was 0.57. Okay, so when you read 0.57 here, 0.5 under 7 is 0.2157. So you add that to the 0.2157. And then you get your final answer. What do you get? When you add this one to this, you get 0.5. when you add these two together, 0.5208. Yes, 0.5208. So that is how you get. So the chances that demand for carpet will be between 52%, will be between 3,000 and 5,000 is 52% approximately. The chances are quite a little over 50%. Yes, Emmanuel.
Okay, so I wanted to ask if the inequality sign would be less than or equal to, since it's between 3,000 and 5,000.
Okay. To be honest, there is no hard and fast rules as to whether it is in less than or equal to or less than. Either way is fine.
Okay.
Because the line is part and the line might not be part. So either way is fine. How you write it, either way is fine.
Thank you.
Now let's go to the next one. The next one, and probably we'll jump the next one. What is the probability that demand for carpet to be at least 2,000? This one is a little bit tricky. Yes, Amina.
Yes, sir. Please, I wanted to find out when we computed the Z value for the probability for the 3,000, we got negative 0.86.
Right.
I don't know if the negative sign has any impact on the reading in the normal distribution table.
Okay, I think you didn't listen to me at that very point. I indicated that it has no impact on the reading on the probability. But later on, when you are not reading it from the probability, it will have an impact. Okay. What I mean is this. Now we have been given X values. We are using the X values to get the Z values. Then we use the Z values to get the probability. That's what we are doing so far. When we finish, we'll go the other way around. Okay. We're going to go backward. Where we would rather be given the P value, we have to use the P values to get the Z. Then we have to use the Z to get the X. At that point, the minus play a role. And we'll come back to that. And the minus is normally for the Z. Remember, it's not for the P or the X. It's for the Z. All right. So if we check this next one, at least 2,000, I'm not going to do it, but I'm going to show you the drawing. Okay, we are going to do at least 2,000. You see the symbol at least is greater or equal to. Then the last one, you see that we also have above 2,000, but below 5,000. We'll also draw that one. So first, let's look at least 2,000. How do you draw that? At least 2,000. How do you draw it? Because how you draw and how you interpret that drawing is all you need. That's all. The rest is just calculation. So to do at least 2,000, you just have to have your value here as always. Do your normal curve. Your mean should be written as always. Your standard deviation should be below it. 2,000, is it to the right or left of the 4,200? Well, when you check it, okay, the 2,000 is to the left. So the 2,000 must come somewhere down here. That is 2,000. Okay. But he says at least 2,000. So we have A, B, C. Which place will be shaded if we were to do at least 2,000? Which place will be shaded? Is it A? Is it B? Is it C? I mean, it says A. Patrick says B and C. Esther says A, B, and C. Oh my goodness. This is interesting. You guys, you are today I've slowed down. And yet some are kidding me. How can it be A, B, and C? When A, B, and C will give you 100%. Yes, Abu Bakar. All right, so it's supposed to be B and C, at least 2,000. So this is the area you have to shade. Okay. Now, once you shade this, what do? You find the Z value for 2,000. And remember, the Z value for 2,000 will be from the center to here. Then you go and read that value on the table, the Z value. Whatever answer you get, you add it to 0.5. So whatever answer you get for the probability of reading for that 2000, okay, you add that to 0.5, and that will give you your final answer. I'm not going to do that. It's fairly simple to give you the B and C. Okay, because whatever you had, you read, gave you the value for B. So you just have to add 0.5, which is a C. What about if the question is this last one? This is the trickiest problem. The probability that demand for copper to be above 2,000 but below 5,000. Above 2,000 but below 5,000. Draw it. Draw it. Normally that's the first thing you want to do. And so once again, you show your mean. You show your 4,200. You show your 1,004. Then above 2,000. So first you need to know where your 2,000 is. And when you look at it, 2,000 is below here. So we indicate that 2,000 first. Now the next one is 5,000. 5,000 is to the right of the mean. So that will be above here. So again, you indicate 5,000. But we are told that it is above 2,000 and below. So now let's go to the spaces I'm going to show you. We have A, you have B, you have C, you have D. Which area are we looking for here? Which area are we looking for? Pay attention to your own rescue. Which area? What is the probability that demand for copper to be above 2,000 but below 5,000? Which area are we shading? Think. Oh, Pelech in Kappa, you have been here since 1944. Think for me. Do something. Say something yourself. You are watching others talk. You are not talking. I won't mention names, but somebody says that B is wrong. Okay. The majority of you are getting it correct, and that is B and C. B and C is the right answer. So now that you know it's B and C, you have to find 2,000, the Z value for 2,000. Okay. Then you find the Z value for 5,000. And then what do? You add the two of them. Okay. Read the Z value for 2,000 to get a probability. Read it for the 5,000, get a probability. You add it two, job done, finish. So everything that you see here is as a result of thought. If you go through the slide, you see that I've done all of them here. Okay. In fact, let me see what I have the last one. Okay. All of them have been nicely executed. This is at least 2,000. This is the last one here. Okay. And when you do that, you add them. The one I just said you add. This is it. So this is a 2,000. This is a 5,000. You add them, you get 66% approximately. Good. Now, let's look at a scenario. You see, once we have been able to get the Z value, we can get the other ones. The formula for the Z is this. Z is X minus mu over sigma. So that is when I don't know the probability and I need to use Z to get a probability. But what if I know the probability and I need to use Z to get an X? I don't know the X, but I know the probability. So at first, we were being given the X, we used the Z, and the Z helped us to get a probability. Now, if we know the probability, we'll use the same Z, that's why it's standardized, to get the X. And that's the next thing we want to look at. That simply means that if you want to get an X from here, from this question, you make X the subject. To make X the subject, you just cross multiply, and that will give you Z sigma equals to X minus mu. If you want X, you move the mu to the left-hand side. Okay. So you have the Z sigma. When the mu comes to the left-hand side, it becomes plus. That's equal to x. So x is equal to sigma, z sigma plus mu. Very cool. So if I know the probability, I can use it to get to the z. And that part is a very tricky part. Once I get a z, I can easily get an x. Let's take a scenario. Suppose the price of Wache is normally distributed with a mean of 8 cedis. The standard deviation is 15, by 5 cedis. Watch, the price of Wache has a mean of 8. So the 8 here is the price of Wache, but it's the average price of Wache. Now I want a particular price of Wache. It says, what should the price be? It's asking for X. So that only 20% of all prices are below this price. This is a tricky part. Only 20% of prices, of all prices, are below this price. Now, to be able to understand this grammar, you need to draw. Okay. Some of the drawing, you will not be able to specify them the way we used to specify because you don't know some of the items. So first, let's draw our normal curve. We have been told that the price of Wache is normally distributed. So we just indicate the normal distribution. We are told that the mean is 8 cedis. So mu is 8. We have been told that the standard deviation is 5. So as always, the standard deviation is 5. We were not told of the x. We are rather to find the x. Okay. So now, as to whether that x value, so this is all x, as to whether that x value is to the right of the mean or to the left of the mean, right now, we don't know yet, but the next percentage question will help you. Guys, pay attention here. Pay attention. For the first time, pay attention. Anytime you look at the area under this normal curve is how many percent? 100. Now that 100%, it rises from 0. So if I were to move in percentage terms, not in x terms, 0 will be here. And what do you think will be the percentage here in the middle? What will be the percentage value? Come on. At the mean, what will be the percentage value in the mean? If we're 0 is here, is the starting point. What will be the percentage value in the middle? 50%. Okay, good. Now watch this. So you're right, 50% to be in the middle on your movement. So remember, we are making a movement like that. Okay. Now, if I am talking about 70%, will it be to the right of the 50% or to the left? 70%. 70. Is it to the right or to the left of the 50%? Pay attention. If you are not following me, you'll be lost. It is to the right. Now, 10%, will it be to the right or to the left of the 50? 10%. Will it be to the right or to the left? It will be to the left. Okay, good. Now, you have been told that 20% of all the prices are below a certain price. So I'm looking for something, right? Pay attention here. I'm looking for a price. The mean price is 8. The price can be above 8, it can be below 8. But what we know is that 20% of all prices are below this price. So if I assume, watch this, if I assume that the price I'm looking for, I don't know the price, or suppose I assume that this price is a question mark and is here. If I choose this question mark here, which I don't know now, I am saying that 20% of all the prices here are below this price I have chosen. That means that I'm saying that from here down to 0 here is 20%. Would that make sense? No, because we know that where I have marked, it is even more than 50%. So that cannot be the price. The next one, it says 20%. Only 20% of all prices are below. Now, if this is 50% and this is 20%, then 20% will be here. In fact, let me delete this one and then come and properly write it. So 20 will be to the left of the 50%. Okay, so you indicate this 20%. But you see, the issue was not the 20%. I'm writing percentage. But I don't want to use percentage because I don't want to write it on the x-axis. Otherwise, it will look like it's x. So I'd rather write it at the top here and say that from this distance up to here is 20%. So this shaded area is 20%. It's 0.2. Now, the question is that 20% of all prices are below this price. So yes, the shaded area here is something that is below 20%. So there's a price, this question mark price, I don't know. I don't know this price. It's an X value, I don't know. But what I know is that 80% of the prices are above this price. Let me repeat. I don't know this question mark price. This X value, I don't know. But what I know is that 80% of the prices are above this, and 20% of the prices are below this. So the English you listen to will help you to know where to place the X. So that's how it is. So 20% of the prices, all prices. So all of the prices down here are 20%, which are below the price I'm looking for. So what is the price I'm looking for? Well, the fact that I know that 20% of the prices are below this price is a good guess. If this shaded area is 20%, what is this area? What is this B area? Who can tell me? What is that area? If this area here is 20%, what is this B area? That's it. Excellent. Terence, Newton, Solomon, and Diana. I mean, it's 30%. Okay, it's 30%. And so now that I know that this is 30%, which one will I take? Will I take the 20% or 30%? You have to take the 30%. Why? The reason why you have to take the 0.3 is because I told you that whenever we were doing normal reading, we will normally start from the center and go through this one before we normally find the area. So the fact that he has given us the 0.2, it doesn't mean that's what exactly you are looking for. Because when you were reading to find x, which is what we are looking for, we're looking for x, you will normally pass 2.3 before you get to that section and then find the value of x. It is a 0.3 you normally read from the table to get a p, and it's not a 0.2. The 0.2 is normally when you have read, then you subtract, then you get it. So now we are looking for 0.3. That 0.3 is a probability. So the probability now is 0.3. How do we get this probability? Because it's only when we know this probability, then we can find the Z equivalent. Or we can find the probability. Trust me, we can. Go to the table. When you go to the table, you know the big space is the probability. Everything you see in this swimming pool, this entire swimming pool is a probability. So you're going to search for a number that is closest to 0.3. In fact, the way the probability numbers have been arranged will tell you that you can easily find 0.3 because you have 0.4 down here. All of these down here are 0.4. So you don't even go there. The 0.3 is just above them. So to get 0.3, 0.3 means 0.3000000. So you just have to go to 0.29999 till you get to 0.3. Okay. So now you start combing here. Look at where I am. Okay. Start combing here. Start combing here. Good. So now watch it carefully. You can see that I have some two numbers here. I have 0.2995 and then 0.3023. Which one is closest to 0.3? That's what you are looking for. These are the only two numbers that are closest to 0.3. Which one? Is it 0.2995 or 0.3023? If you guess you are wrong, you are perfect. So the correct answer is 0.299. This is closer to. Now that you know, then you should read its z value now moving leftward and upward. So when you read its z value, you go leftward and then you go upward. So what would be the z value, the equivalent z value? Type it there for me. What would be the z value? Excellent. It would have been 0.84. That would have been the z value. But for some reason, you have to add the negative. Who can tell me why? For some reason, you have to add a negative to the 0.80. Why? Reason is because we will notice that the x we are looking for, that value, that x we are looking for, it is to the left of the mean. The mean is 8, and the value we are looking for is to the left of the mean. So whatever z value you get, okay, once we are working in the area of the left of the mean, whatever you get, it is that. So z is actually negative 0.84. That's it. Now substitute it into the formula. What is the z formula? The z formula is z equals x minus mu over sigma. We know the value of z now. It is negative 0.84 equals to x. We don't know the x. That's what we're looking for. Minus the mean. The mean is 8. Divided by the standard deviation. That is 5. Find your x. Cross multiply. Group items. Simple. Find me your answer. Who is done? Whatever answer you get, remember it will be below, it's supposed to be below the mean of 8 because it's to the left of the mean. So you should not get 3.8 exactly. Is it 3.8 exactly or 3.8 something? Maybe it's 3.8. All right, it's 3.8. So you got 3.8. So that is the price you're looking for. So it means that 20% of the prices are below 3.8. The 20% of the Wache prices are below 3.8. That is how you find this. Now, suppose the 10 had been, what is the probability? It says that what should the price be so that, listen to this, instead of 20% of all the prices, if you have said, so that 40% of all prices are below this price. 40% of all prices are below this price. So instead of 20%, it says 40% of all prices. What probability would you read? If 40% of all prices are below this price, and you were going to read the probability, what probability would you have read from the table, which will help you to find the z? What probability will you dump into the swimming pool to search for? 10%. Excellent. Very good. Okay. Now, but that is because of the word below. Suppose you have been told that what should the price be for the top 10%? What should the price be, for the top 10% of the prices? What should the price be for the top 10% of the prices? Top 10%. What should the price be for the top 10% of the prices? What would you have said? Oh, what probability would you have read? What probability would you have read? Top 10%. Top 10%. Your top 10% area would have been what? What probability would you have read? Let me see whether they are smart guys. Oh, they are really, really, really smart guys. Excellent. Christopher is smart. Emmanuel is smart. Okay. Top 10% means that we are talking about 90%. Okay. Top 10% means that we are looking at the top 10 here. But before you can get that top 10, you have to pass through 40%. So you're going to read the 0.4 from the table. That's what you're going to read. That's the probability. So it means that the probability is 0.4. So you got to read 0.4, find the z, substitute, and then that will give you the x value for the top 10%. Very smart. Now, last one. What do you think the price will be for 70% of the prizes? What will be the price for the 70% of the prizes? What will be the price, or let me put it this way, what will be the price below 70% of the prizes? What will be the price below 70% of all prizes? What will be the price below 70% of all prizes? What probability would you read? A lot of things go into your mind before you know the probability to read. What will be the price, okay, below 70% of all prizes? What probability will you read? Oh my goodness me. Christopher is smart. Christopher Morgan, watch that guy. These are the people you should befriend, not the one you are befriending. Okay. Christopher, that is a 70% means that you have 50% and 20%. And so what it means is that you should go and read, because the 50% we are done with. Okay, but that one is on the left side. So it's still 70% is on the right, but you're going to read the 20% part of the 50%, or the 20% part after the 50%. So you are going to read 0.2 on the right side, which is going to be positive. And then that is what you use to get your Z value. How you do anything is how you do everything. I want to repeat that. How you do anything is how you do everything. What do I mean? If you think you cannot do it, you cannot do it. You close your mind, this thing is, you cannot. But if you say that, look, I get it, but it confuses me a little, but I'll get it. I get it, but it confuses me a little, but I'll get it. You will get it. So go and look at several of these scenarios, and you will see that it's really, really cool to be able to look at that. All that we did are also here. Look at that. Now, in conclusion, this is a general question. There are several questions actually in your slides you should check. And this is one particular question that was a little bit tricky. Let me see whether we can crack that before we go. Very, very quick. This was an exam question. The salaries of Volta region polling agents for 2012 election in Ghana are normally distributed. The salaries. There's a mean of 1,050 Ghana cedis. There's a standard deviation of that. Now, Volta region has 620 of these polling agents to help with the election. The agents get over 1,002 cedis. The agents who earn over 1,002 cedis are also given bonuses. That is, if you get 1,002. But remember, the mean is this. But if you get over 1,002, you are also given a bonus. Now, question is, how many polling agents can qualify for this bonus? Correct to the nearest whole number. How do you solve it? Well, the basic thing you got to do, okay, normally I leave it for you to do, but I'm not doing this, is to draw your curve as well. The mean is what? The mean is 1050. The standard deviation is what? 120. So first, you need to find over 1,002. Is it to the right or to the left of the mean? It is to the right. So just indicate 1,002 here. Is it above 1,002 you're looking at? Yes, because of the word over. So you're shading this. That's right. To get that area, you need to find this one, B. Okay, and then subtract the B, the probability of the B from 0.5. But watch this. You have to use a Z-table. So Z will be 1,002 minus 1050 divided by, somebody should find the answer for me, divided by 120. So 1,002 minus 1050 is 150. So you have 150 divided by 120. That is 1.25. So you go to your table, you go and read 1.25. That is 1.2 under 5. This is 1.2, and this one is under 5, which is 0.3944. So your value you had for this B, the value you're going to get for this B, okay, is going to be 0.39. Oh, I've forgotten the answer again. 0.3944. Good. Oh, come on. 0.3944. So that is the answer that you have, but that's not what you're looking for. You subtract that from 0.5. What do you get? You get 0.5 minus 0.3944. That will give you 0.1056. You see how I'm working it myself. Now, so that is a percentage of those getting over 1,002 and are going to get, they're going to get bonuses. This is a percentage value. That is 10.56%. The question is, how many pooling agents can qualify? Well, we know that out of the pooling agents we have, 10.56% of them are going to get bonuses. And how many are they? They are 620. So you just take that 620, you multiply it by the point, blah, 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 and that will give you, the question was very specific, nearest to the whole number, and that will be 60. Actually, that will be 65.472. So nearest whole number will give you 65. So out of the 620 pooling agents, 65 of them had bonuses, qualify for bonuses. So this question itself is a usual question, but after that, you got to multiply it by the sample that you were given as well. Who was able to get it whilst I was doing it? Amino. Very good. Amino was right with me. Ladies and gentlemen, that brings us to the end of the entire model. Wisdom is with the learned one. The only way to understand knowledge is to have knowledge. But the one knowledge that I'm giving you today is as a result of some knowledge you already have. Everything I worked is here, by the way. So you should always have knowledge to be able to understand. So go look at some of these things yourself, work them, and then you can be able to get basic things. I bring this to an end, but I know you have questions. If you have a question, please raise your hand and let's address them.